Okay, chapter 6. We're talking about similar figures, a little bit different than what we've talked about before with congruent figures, and I want to make sure that you see the difference between different symbols. So these three symbols are very similar, and I want to make sure you see the difference. Congruent is something that we talked about a lot in previous chapters. It's the equal sign with a squiggly line above it. Congruent means same size and same shape. They're the same figure. This is a symbol that you'll see quite a bit when we get to the trig unit. This means approximately equal. This means that you're comparing two values. Or a lot of times if you are getting an answer, something like x equals 1/3, and you change it to a rounded decimal, you can say x is approximately equal to 0.3. That's when you'll see that is when you're either rounding or you're estimating. You can use that symbol of approximately equal to. This is the one we're going to talk about today, similar. So it's one squiggly line. That means it's the same shape with a different size. That's exactly what you're doing for your project. These three ideas are new today, which you need to understand. Two polygons are similar. There's two important parts if they're similar. Corresponding angles are congruent. Corresponding sides are proportional. So remember, when we did congruent figures, all the angles are congruent, all the sides are congruent. This is a little different. Corresponding angles are congruent, corresponding sides are proportional. Corresponding is important. If you remember back when we did parallel lines, there's a set of parallel lines, there's my transversal. Corresponding angles were in the same location. So those two angles that I marked are corresponding. They're in the same location. We're using the same idea when you talk about corresponding angles. They're in the same location. So if they're in the same location, they're the same. Corresponding sides are proportional. In other words, you're using a scale factor, a consistent scale factor, to either enlarge or make sides smaller. A scale factor is the ratio of the side lengths of two corresponding sides. And if two polygons are similar, the side length ratio and perimeter ratios are the same. This is important because this is going to be a shortcut for you. So this basically says that this scale factor that you're finding will be the same of your side length ratios and your perimeter ratios. That's going to link some things and make your job a little easier for some of the problems we're going to do. Here's some important vocabulary for you to understand. You need to understand the difference between a similarity statement, a scale factor, and statement of proportionality. A similarity statement looks like this. This says triangle ABC is similar to triangle DEF. The order is important because the order is going to show you what angles are congruent and what sides are proportional. So by looking at this, I can say A and D angles are the same, B and E angles are the same, C and F are the same. Be careful when you're checking your work with mine. Yours may be in a different order and still correct. For example, if you wrote down triangle CBA is similar to triangle FED. They're still the same because it shows that C and F are corresponding, B and E and A and D, which is the same as what this one's saying. So be careful that if yours doesn't match mine, it might mean that you're still correct. So a similarity statement. This one's for a triangle. If it's not a triangle, you're just going to name it using all the vertices. You won't have a symbol out front like the triangles do. Same idea. Scale factor. You're going to stay consistent with the way the similarity statement is. So the ABC number first, the DEF number last. You have to find two sides that are corresponding. I'm going to use AB and DE. They're in the same location. So AB has a length of 3, DE has a length of 6. And of course you're going to simplify, so that scale factor is 1 to 2. So that scale factor is showing the relationship between the sides. Statement of proportionality. This is showing the relationship between the sides. So proportional, it's going to look like a proportion, but it depends on how many sides. If it's a triangle, you're going to have 3 ratios. If it's a quadrilateral, you would have 4, and so on. So what I did was, I think using this is easier, but you can also look at the picture because it's a pretty simple one. This is showing that AB corresponds to DE. Looking at the picture, AB and DE are corresponding. Looking at my similarity statement, AB, DE, similar to what we did when we looked at congruent figures. BC and EF, BC, EF, BC, EF. And the last one, AC, DF, AC, DF. Just like I've talked about with other proportions, my top numbers are my ABC numbers, my bottom numbers are my DEF numbers. And setting it up kind of like a grid, this is like my left sides, this is like my right sides, and these numbers are my bottom ones, if you want to look at it that way so that you put things in the right spot. Look at example 1. We're given a picture, or a smaller picture and a bigger picture, and you're also given a statement of a similarity statement. I want you to notice the difference between this one and the one we just talked about a minute ago. Because these are quadrilaterals, you're going to have 4 vertices to label it with instead of 3, obviously, from a triangle. It says list all pairs of congruent angles. You could use your picture. It's much easier to use this. So my congruent angles. Angle W is congruent to angle M. Angle X is congruent to angle N. Angle Y is congruent to angle O. Angle Z is congruent to angle P. I got that from here. W and M, X and N, Y and O, Z and P. The next thing asked me to write a statement of proportionality. Remember what that looks like. Again, I'm going to use this because it's much easier to me than using the picture. So WX is the same as, or is proportional to MN. XY is proportional to NO. YZ is proportional to OP. Hopefully you're following along from here where I'm getting this from. And then WZ is proportional to MP. So this is my statement of proportionality. My next example, it says, are the polygons similar? There's a couple ways you can figure out if polygons are similar, and I want to show you all of them. This is a simpler problem, but they're going to be harder for homework and future problems, so I want to make sure you know how to figure them out. So to figure out they're similar, we want to see if they're proportional. So what I did is I came up with fractions or ratios to see if we have the same relationship. So I did 6 over 24, 6 over 24, 4 over 16, 6 over 24, 4 over 16. Came up with those ratios using corresponding parts. All of those ratios I wrote here. When I simplify them, I got the same fraction, the same ratio. So because I got the same fraction, I can say yes, they're similar. So that's one way to do it. Write up corresponding ratios and simplify them. If you get the same answer, then the figures are similar. The other way you can do that, using these ratios, you can plug them in your calculator and see if you get the same decimal. 6 divided by 24 gives you 0.5, 4 divided by 16, 0.25. Dividing it out, you get 0.25 for all of them. Because I get the same relationship for all of them, again, I can say that they're similar. There's one other way to do it with a more complex problem. We can show that the figures are proportional. So what I did was come up with a proportion. 6 over 24 equals 4 over 16. These cross products are the same. 6 times 16 is the same as 24 times 4. Because the cross products are the same, I can say yes, they are similar. If the cross products are different, that means that they are not similar. So that's 3 different ways to show you that yes, the polygons are similar. So yes, they're similar. The next part says, if so, write a similarity statement. Be careful that they're in the correct order. I said WXYZ. WXYZ is similar to DABC. Be careful, the orders are not always going to be alphabetical, so be careful they're in the correct order. Find the scale factor. Because this is how I wrote my similarity statement, I'm going to stay consistent. I picked a side from WXYZ of 24, then I picked a corresponding side of DABC, which is 6. When I reduced it, I got 4 to 1, which is my scale factor. One more problem I want to look at. This one did not give you a picture, so the black is what's given to you, the red is my work. The first statement is my similarity statement. It says triangle ABC is similar to triangle DEF. ABC is isosceles, so I put these two markings on here. Isosceles means that I have two sides congruent. ABC is a perimeter of 18 inches and a leg length of 5 inches. With an isosceles triangle, the legs are the sides that are congruent. This is the base. So because these are both 5 because they're congruent, because it's an isosceles, I mark both of those as 5. The base of DEF is 34.4 inches long. So again, here's my isosceles. This one's also isosceles because it's similar. So these two are the sides that are congruent. This is my base, so I labeled that as 34.4. It also tells me that the perimeter of ABC is 18 inches, so I mark that down. They're asking us to find the perimeter of DEF. The only thing that's not marked that I can figure out is the base of this triangle. So I knew that these two were 5 because it's given to me. I knew that the perimeter is 18. So if these added up to 10, in order to get to a perimeter of 18, this has to be 8. So because we're trying to figure out the perimeter, I have to find a relationship between the two. I don't have a relationship between these two corresponding sides or these two corresponding sides. I don't have a relationship between the perimeter, but I do have a relationship between the bases. So when you set up your proportions, set it up like a grid. If you notice how I set up my proportion, this first column is my base numbers. My second column is perimeter numbers. Top numbers are ABC numbers. Bottom numbers are DEF numbers. So if you follow me, that grid will help you put things in the correct spot. So the base of ABC is 8. That comes from my picture. The base of DEF is 34.4, again, comes from my picture. What we talked about at the beginning of the video, we said that the perimeter and the side length ratios are the same. That's why I'm allowed to set this up the way I did. The perimeter of ABC is 18. And then of course you should know how to solve this proportion. 34.4 times 18, divide by 8. That gives you 77.4 inches as my DEF perimeter, which is what they asked us to do. Your homework for 6-3. And of course my notes and my homework key is posted online, and I'll answer any questions that you have.